Good morning. Good morning, Rakshita. Good morning, Faiza. Good morning, YouTubers. Good morning, everyone. Good morning. Good morning, Nikhila, Nagalakshmi, Android, Sudeshna, Sara. Namaste, Harshita. Good morning, Subhash, Akhila. Good morning, Yashwant. Good morning, Charita. Good morning, everyone. Good morning Isha, good morning Medha, good morning Amruta, Achyuta, good morning, YouTube, good morning M Siri, good morning Anya, good morning Devki, good morning Gayatri, good morning Zenat, good morning Perfect Home, good morning everyone. No, I did not have my breakfast yet, boys and girls. What about you? What about you? Good morning, Uday. Good morning, Lakshmi. Good morning, Omkar. Good morning, Sudha Putti Sangvi. Good morning, Afreen. Good morning, Archana. Good morning, Honey. Good morning, Ruchita. Good morning, everyone. I am absolutely fine. What about you? Drinking bed coffee, ma'am. Wow. Bed coffee. Good morning, Bhaskar. Good morning, Ashish. Good morning, Niharika. Very good morning to all of you. Good morning, Upendra. Good morning, empowered youth. Good morning. Good morning, Dheeraj. Good morning, Kusuma. Everybody, good morning. Hope you are having a good day. Hope you had a good morning. So, today I would be finishing with your morphology part. Okay? Today I will be finishing off with your morphology part. Okay? Yes, Redmi. Yes, Lakshmi Ram. Today is the last class. I hope so. Okay. Yes, tomorrow I think gift to exam will be there. Yes, it will be there. Yes, exam will be there as usual. Syllabus will be from the part that I have taught you in this week. Yes, Yashwant. Okay. So, let us start the topic today. Let us start the topic today. Yes, Pritam, tomorrow is space exam. Tomorrow is the last class of morphology of flowering plants. Okay. Now see. Let us revise once whatever we have done. Let us revise once whatever we have done. Yesterday, what did we study? Yesterday, we studied placentation. Yes or no? When I gave you the QR code, when you scanned the QR code, did you also get the diagrams? Did you also get the diagrams, boys and girls? Yeah. So it might have become easy for you. Okay. Now, let me tell you. Tell me in which placentation placenta is at the center. Placenta is at the center. Ovules are also attached to the placentation, but it is multilocular. Placenta is at the center. Placenta is at the center. Ovules are attached to the placenta, but it is multilocular. Come on, which type of placentation? Yes, it is axile placentation. Now, can you tell me, if I would have said that placenta is at the center, ovules are attached to it, but but it is unilocular, but it is unilocular, but it is unilocular, unilocular, unilocular. Yeah, very good. It will be free central. It will be free central. It will be free central placentation. It will be free central placentation. Very, very good. It will be free central placentation. Very, very good. Okay. If I tell you the placentation which is characterized by false septum or replum, the one which is characterized by false septum or replum. Yes, can you tell me which is the placentation? Which is the placentation? Yes, it is parietal placentation. Yes, it is parietal placentation. Very good. It is parietal placentation. Can you tell me example of parietal placentation? Can you tell me example of parietal placentation? What is the example of parietal placentation? Right. Mustard, argemone, cucumber. Mustard, argemone, cucumber. Very good. Can you tell me the placentation? Can you tell me the placentation in which there will be a single ovule attached to the base of the ovary. Single ovule attached to the base of the ovary. Basal placentation. Basal placentation. What is the example of basal placentation? What is the example of basal placentation? Yes, it is sunflower and marigold. It is sunflower and marigold. Now, two small topics are left. Now, two small topics are left. One is your fruit. So now we are going to start with the fruit. Now we are going to start with the fruit. When I talk about fruit, who is the one which is forming a fruit? Ripened ovary. Ripened ovary is responsible for formation of fruit. Ripened ovary is responsible for formation of fruit. Ovary consists of ovary wall. Ovary consists of the ovary wall. Ovary consists of two things. What is the first one? The first one is the ovary wall, or it is known as the fruit wall or pericarp. I said you yesterday, the ovary wall or the fruit is the fruit. It consists of what is the first thing? Ovary wall. The second thing that it will consist of is the ovule. The ovule later on form the seeds. So ovary consists of seeds and ovary consists of the fruit wall or pericarp. Pericarp can either be fleshy. Pericarp can either be fleshy or it can be dry. Pericarp, that is the fruit wall, can be fleshy or dry. The fruit wall is fleshy in mango, orange and guava. The pericarp, that is the fruit wall, is fleshy in mango, orange and guava. But the fruit wall is dry in case of mustard and groundnut. Pericarp can either be dry or fleshy. If it is fleshy pericarp is found in mango, orange, guava. Okay, dry pericarp is found in mustard and groundnut. So the ripened ovary is called the fruit. The ripened ovary is called the fruit. It consists of two parts. One is the ovary wall, fruit wall or the pericarp, and the second one is your ovule or the seeds. If the pericarp is fleshy, it is found in mango, orange and guava. If it is dry, pericarp is mustard and groundnut. Now, pericarp in case of fleshy fruits. Now I am writing pericarp in case of fleshy fruits. Pericarp can be differentiated into outer epicarp. Pericarp can be differentiated into outer epicarp. It can be differentiated into middle mesocarp, and it will be differentiated into an inner layer which is known as the endocarp. Which is known as the endocarp. Okay? No, Pragna, coconut has epicarp, mesocarp, endocarp. Okay, so if pericarp is fleshy, boys and girls, if the pericarp is thick and fleshy, if the pericarp is thick and fleshy, then it will be divided into 3 layers: outer epicarp, middle mesocarp, and what? Inner endocarp. Yesterday I told you that this is your ovary, this is your ovary wall, this is your ovary wall, this is your ovary wall, this one is your ovary wall or fruit wall. And what else we have inside the ovary? That is going to form a seed, and this is your ovary wall or fruit wall. Okay, so fruit wall is known as pericarp. Pericarp is fleshy. It is found in mango, orange and groundnut. Another thing which I told you, that if pericarp is thick and fleshy, it will be differentiated into outer epicarp, middle mesocarp and inner endocarp. Also, pericarp can be dry in mustard and groundnut. Am I clear to everyone? Yes or no? Am I clear to everyone? Yes or no? Am I clear to everyone? Yes or no? Please reply. Is it clear? Yes or no? Okay. Now, in your NCERT, 2 examples are given: mango and coconut. Mango and coconut. 2 examples are given. One is your mango, another is your coconut. In your NCERT, it is mentioned that mango and coconut are which type of fruit? Drupe fruits. Which type of fruit? Drupe fruits. Mango and coconut, in your NCERT, it is mentioned that they are drupe fruits. What are drupe fruits? What are drupe fruits? Drupe fruits develop from monocarpellary superior ovaries. Mango and coconut develop from monocarpellary superior ovaries. Mango and coconut are known as which type of fruits? Drupe fruits. Okay, it is given in your NCERT also. Mango and coconut are known as drupe fruits. They develop from monocarpellary superior ovaries. They develop from monocarpellary superior ovaries and are how many seeded? 1 seeded. And are how many seeded? 1 seeded. Very, very important. Mango and coconut are known as drupe fruits. They develop from monocarpellary superior ovaries and are 1 seeded. Am I clear till here? Yes or no? Avyukt it has. Am I clear yet? Yes or no? Am I clear? Tell me, boys and girls. Am I clear? Yes or no? Okay, now next I will tell you what are the parts in a mango. What are the parts in a mango? Okay, so this is your mango. Sorry. This is your mango. The outer part that you eat, that is your pericarp. The outer superior ovaries, Charan, means what? What do you mean by superior ovaries? Hypogynous ovary. Hypogynous ovary. Hypogynous ovary. Hypogynous ovary. Okay, I think there is a lot of bend for my mango over here. I think nobody will consider it mango. Now, see over here. This is your mango. This is your mango. The outer part that you do not eat, the outer part that you do not eat, that you throw away is your epicarp. It is the fruit wall. Pericarp is differentiated into three types: outer epicarp, middle mesocarp, and inner endocarp. This is the outer side which is known as the epicarp. The inner side that you eat, is fleshy. It will be known as the fleshy mesocarp. It will be known as the fleshy mesocarp. It will be known as the fleshy mesocarp. Am I clear? Yes or no? So this entirely becomes your mesocarp. This entirely becomes your mesocarp. Am I clear? Yes or no? This is the outer layer which is yellow in color. I am writing over here. It is yellow in color. Fleshy part is the mesocarp which you eat. Now, when you eat the whole mango, can you see in inner side there is one hard structure? A hard structure is present, yes or no? Whenever you finish eating mango, there is a hard structure, whitish in color, which you suck and eat, yes or no? That is the endocarp. That is the endocarp. That is the endocarp, my dear. That is the endocarp. That is the endocarp. Okay, it is stony. Epicarp is thin. Endocarp, that white color is the endocarp. Now if you see the endocarp like this, you will hear that inside it there is the seed. If you do like this, you will see that something is there inside. If you are going to do like this, you will see something is there inside. That something is your seed. So in a mango, you have outer thin epicarp. You have middle fleshy mesocarp. You have inner stony endocarp. Am I clear? Yes or no? You have a outer thin epicarp, you have a middle fleshy mesocarp, and you have a inner endocarp. Am I clear to everyone? Yes or no? This is for mango. What is the next one we are going to study? Coconut. What is the next thing that you are going to study? Coconut. Now, when you drink water of coconut, which is now very common, outside is green in color. This is coconut. You are drinking coconut water, yes or no? So this is your pericarp. This is your fruit wall or pericarp. The green colored structure of coconut from which you are drinking water, that becomes your pericarp. Now, how are coconut found on trees? Remember, wait, I will show you. How are coconut found on trees? I will show you. Can you see this image, boys and girls? Can you see this image, everyone, boys and girls? Can you see, everyone, boys and girls, this image? Can you see? Yes or no? Tell me. Can you see this image? Now see over here. Coconut is found like this, yes or no? When you are eating coconut, this portion is your green color. But when it becomes brown, the outer layer is known as the epicarp. The outer layer is known as the epicarp. Okay? The outer layer, this layer is known as the epicarp. Okay, now when this coconut comes outside, it looks like this. This is very fibrous in nature. Yes or no? This is very fibrous in nature. This portion is known as the mesocarp. Fibrous mesocarp. Coconut is a drupe fruit, but it has got fibrous mesocarp. Okay, this is the endocarp. Endocarp over here is non-edible. And inside is the white structure which you eat. Can you tell me, in coconut, the white structure is your endosperm. This is how a coconut looks. When you are seeing a tree, from the tree you are getting this type of coconut. Yes or no? From the tree you are getting this type of coconut. Okay? So I will be drawing the same diagram or more. Same diagram I would be drawing over here. When you see a coconut from the tree, you get it like this. After that, this is your coconut. Okay? And inside the coconut, it is what in color? It is white in color. Inside of the coconut is white in color. This is the white part of the coconut. You get the coconut like this. This is the white part of the coconut which you are eating. Okay, so what is this? This becomes your epicarp. This becomes your non-edible endocarp. Inside this wide edible part, it is your endosperm. Both the coconut water as well as the white part of the coconut is endosperm. No, Dheeraj, endosperm and endocarp is not the same. When the embryo needs food, it depends upon the endosperm. Endosperm is very nutritive. Now, when you take this coconut outside, how does the coconut look? Like this. And outside there are these fibers. Okay, this is known as the mesocarp. In coconut, they have a fibrous mesocarp. When you take this coconut outside, you will see mesocarp. And what is this? This is your endocarp. Am I clear to everyone? Yes or no? Yes or no? Have you understood mango and coconut? Tell me in the chat box. Have you understood mango and coconut? Tell me in the chat box. Have you understood? Yes or no? Have you understood, YouTubers? Yes or no? Epi means outer, meso means middle, endo means inner. Okay? So what is coconut? When you are eating the coconut, you see that there is a green color portion over here. When you are drinking water, that is the pericarp. Pericarp is differentiated into the epicarp. It will be differentiated into fibrous mesocarp, the coir-like structure, and it will be differentiated into the non-edible endocarp. The white part of the coconut which you eat is your endosperm. You have to remember this. The white part of the coconut which you eat is the endosperm. Also the coconut water, or the white edible part, they are nothing but your endosperm. Endosperm is a nutritive tissue. Okay, Charan Kumar Reddy, I think epicarp is over here. I already said you. When you are going to cut the coconut, you are only going to see the mesocarp and the endocarp. Epicarp is present over here, the big brown coconut. Okay, now fruit is your over, next is your seed. What did I tell you in last class? Who is forming seed? The ovule. Who is responsible for formation of seed? Ovule. Dheeraj, where I said endocarp, I said this is the endocarp, this is the non-edible endocarp. Why are you not following, Dheeraj? You are asking that questions that I am mentioning. I said about endosperm also or endocarp also. I think you cannot see. Same things I am writing. Now, seed. The seed already I have taught you. First, we are going to study the structure of dicot seed. When I studied morphology of flowering plants, I explained to you what is a dicot seed. In your NCRT, the diagram that is given is of a gram seed. This is a gram seed. In the gram seed, there is a small pore called micropyle. This is a gram seed. If you are going to cut the gram seed into two halves, what is the structure that you are going to get? You are going to get two cotyledons. The above part will consist of a plumule. And the portion below will consist of radicle. I said you all this. So this is your gram seed. Gram seed is an example of dicot. Okay, this pore is known as the micropyle. And this pore here, there is a small point called hilum. See your NCRT, it is written. Hilum is the point by which developing seed was attached to fruit. Hilum is the point by which developing seed attaches to fruit. It is a point for which developing seed attaches to fruit. What is the second one? Second one is your micropyle. What is micropyle? It is a small pore above hilum. And what is the function of micropyle? Exchange of air and nutrients. Through the micropyle, air and nutrients enter. Through the micropyle, air and nutrients enter. So hilum is a point on the seed coat. This is the seed coat. This is the seed coat. Hilum is a point on the seed coat. It is a point on the seed coat by which seeds are attached to the ovary. And what is micropyle? Above the seed coat there is your micropyle. What is the function of micropyle? To exchange air and nutrients. To exchange air and nutrients. Am I clear? Yes or no? Now, I already said you dicot seed has how many cotyledons? 2 cotyledons. What is the function of cotyledons? Cotyledons store reserve food. Cotyledons store reserve food. Reserve food in the form of what? It stores reserve food in the form of starch. It stores reserve food in the form of starch. It stores reserve food in the form of starch. Now, what is the part that is above? What is this part known as? This is known as the plumule, and plumule is responsible for giving rise to the shoot. What is this? This is your radicle. Radicle gives rise to the root. And what I said, from the middle, what is there? It is known as the embryonal axis. From the middle, embryonal axis is there. It consists of 2 parts, plumule and radicle. Yes, all dicots have the same structure of seed. There will always be 2 cotyledons. There will always be 2 cotyledons. Okay, it will cover 2 cotyledons. Okay, the part that is the radicle, it is below. It will give rise to a root and it will give rise to a shoot. And what is the function of cotyledons? It stores food in the form of starch. This is the structure of dicotyledonous seed. Am I clear? Yes or no? Am I clear? Yes or no? Tell me. Dicot seed, this structure I have made you study when I studied morphology of flowering plants. When I started with morphology of flowering plants, this same structure I gave you. Same structure. Okay? Now, yes, Xiaomi 22041219I. What is your doubt? Can you please enhance what is your doubt? Or you are writing to time pass? Tell me, what is your doubt? Next, we are going to study structure of monocot seed. In your NCERT, the structure of monocot seed that is given is your maize. Monocot seed structure that is given is your maize. This is your maize seed. This is your maize seed. Now, in a maize seed, what is happening? What is happening in the maize seed? In the maize seed, now what did I tell you? That over here in structure of dicot seed, you have seed coat. What is the outer seed coat known as? Testa. What is the outer seed coat known as? Testa. What is the inner seed coat known as? Tegmen. The outer seed coat is known as the testa. Inner seed coat is known as the tegmen. Okay, you should remember fruit wall is the pericarp, but outer seed coat is the testa, inner seed coat is the tegmen. Okay, if you see in maize what happens, testa testa and pericarp is fused. The testa and pericarp in maize is fused and it is membranous. In maize, the testa and the pericarp is fused and is membranous. So in case of maize, the fruit wall, that is pericarp, and the testa, it is fused. It is fused. The testa and the pericarp is fused, becomes membranous to form a thin, hard covering. Okay? Now, here we will have two parts. The first one is your endosperm. All monocots are endospermic seeds as it retains the endosperm. Dicots are non-endospermic seeds. It is written in your NCERT. Monocots are there which retain the endosperm after maturity. In NCERT, it is written generally all monocots are endospermic. So, this is the endosperm of maize by which the embryo gets its food. This is the endosperm of maize. This is the embryo. This is the embryo. Embryo over here has a single cotyledon. Embryo over here has a single cotyledon, and single cotyledon in monocots is known as scutellum. Single cotyledon in monocots is known as scutellum. Now, this is the endosperm, this is the embryo. It is separated by a alluron layer. What is alluron layer? It is a proteinaceous layer. Alluron layer separates the endosperm and embryo. Alluron layer separates the endosperm and embryo. Alluron layer is a protein layer. Alluron layer is a protein layer that separates the endosperm and the embryo. Embryo over here consists of a single cotyledon. Single cotyledon is known as scutellum. Now, this is your embryo. This is your embryo. Yes, Kaveri, coconut is monocot because it contains endosperm. So, this becomes your plumule. This becomes your plumule. This becomes your radicle. Radicle will later on form the root. Radicle will be covered on the outside by what? Root cap. So here you have plumule and radicle. Here you have plumule and radicle. Over here, the plumule is covered by a covering which is known as coleoptile. The plumule is covered by a sheathy covering which is known as coleoptile. Radicle is covered by a covering which is known as coleorhiza. Okay, so what happens over here? This is your maize seed. In the maize seed, the testa and pericarp is fused. It becomes membranous. I am writing over here monocots. Monocots are endospermic. Monocots are endospermic except orchids. Except orchids, all monocots are endospermic. Rice, wheat, barley, maize, castor, all these are endospermic. What is the next one? Over here, single cotyledon. Single cotyledon is known as scutellum. Over here, the protective sheath of plumule. Over here, the protective sheath of plumule. Sheath means covering. is coleoptile and protective sheath of radical is coleorhiza. Okay, in maize seed the testa plus pericarp is fused to become membranous. It is a thin hard covering. This is the endosperm, this is the embryo. The endosperm and embryo are separated by which layer? Aleuron layer. Very, very important. Single embryo over here is known as scutellum. In monocots, endosperm is present, thus they are endospermic seed. Then who are non-endospermic seeds? Gram seed is non-endospermic. Dicots are non-endospermic. Gram, pea, bean, etc. They are non-endospermic. What is the protective covering of plumule known as? Coleoptile. Protective covering of radical is known as coleorhiza. Have you understood? Yes or no? Have you understood? Yes or no? Tell me in the chat box. Tell me in the chat box. Have you understood? Yes or no? Tell me in the chat box if you have any doubt. Tell me. Have you understood? Yes or no? No, Kaveri, it does not contain endosperm. You can say avyukt, but not modified. In dicots, what happens? Cotyledons is fleshy. That's why it is not endosperm. In monocots, cotyledon is not fleshy. It is thin. That's why it has endosperm avyukt. When you will come to offline classes, I will teach you. Now, root is protected by the root cap as well as the coleorhiza. Okay? Now, your morphology chapter is over. Families, I think you will do it after you come. But I wanted to give you something extra so that you remember me for your whole life. What is that something extra? Like we have studied a lot of examples, yes or no? We have studied lot of examples. So can I give you a chart as in, for example, mustard. Mustard, you have studied many examples. Taproot, it has got dry pericarp. So can I write along with mustard all the topics where we have studied? Can I give a chart like this? Tell me. Can I give a chart like this? It will be very helpful for you. It will be very helpful for you. So I am giving you one example. You see, this is something extra which I do so that you don't face problem. Okay? So first one is your wheat. First one is your wheat. Where have we studied examples of wheat? Wheat has got fibrous root. Wheat has got fibrous root. It is an example of monocot. If it is an example of monocot, then it will be endospermic seed or non-endospermic seed? Endospermic seed. Yes or no? Second one is your banyan. Second one is your banyan. Banyan is an example of prop root because roots are arising from the base of the stem. I am writing and also revising. Please keep your ears open. Okay? Prop root means the roots are visible. So it is aerial root. Also in your NCERT, banyan is given as an example of adventitious root. So prop root, aerial root and adventitious root. Okay. What is the next example? Maize. What is the next example? Maize. Just now we studied that maize is a monocot seed. It is a endospermic seed, and also we have studied that maize is a example of stilt root. Maize is a example of stilt root. Are you finding it helpful, boys and girls? Are you finding it helpful? Please tell me, are you finding it helpful? Okay? Okay. Thank you. Next we studied asparagus. Asparagus roots are in clusters. If their roots are in clusters, it is known as fasciculated root. If you known as fasciculated root. Fasciculated root plus asparagus, we have studied that it is a cladode. It is a cladode. Yes, sir, it is a cladode. Yes or no? It has got limited growth. It is a cladode. Next is your bean. Next is your bean. Bean is a dicot seed. It is also non-endospermic in nature. It is non-endospermic in nature. Bean has which type of estivation? Vexillary estivation. And where else we have studied bean? It is an example of zygomorphic. See, you don't have to learn this. You learn according to topics. I am just writing it so that you feel helpful. That when it is a dictionary type of thing. It is a dictionary type of thing. When you know morphology, very good. When you know morphology at your fingertips, this chart is going to help you a lot. Next is your cassia. We have studied cassia in imbricate estivation. We have studied cassia. It is an example of staminode. What was staminode? Staminode means sterile. Staminode means sterile, stamen. Yesterday, day before yesterday, I taught you. And it is example of zygomorphic. It is example of zygomorphic. Next is your radish. Next is your radish. Radish has which type of roots? Fusiform root. That is, it has got modified taproot. It has got modified taproot. It is an example of polycephalous condition also. It is an example of polycephalous condition. It can also be called as tetradynamous condition, family Brassicaceae. Tetradynamous condition, and it is also example of racemose inflorescence. It is also example of racemose inflorescence. Okay? Now, next page we will write about mustard. Mustard is very important. Mustard has came many times. Let us see where mustard has come. Number 1, mustard. Just now today we studied that mustard has got a dry pericarp. Today we studied mustard and groundnut have dry pericarp. Mustard is an example of tap root system. Yes or no? Can you tell me mustard is which type of flower? Mustard is actinomorphic flower. Do you remember trick MACD? Actinomorphic flower. The next one is mustard has got which type of phyllotaxy? Alternate phyllotaxy. Mustard has got alternate phyllotaxy. Mustard has got alternate phyllotaxy. It is polycephalous as well as polypetalous. It is polysepalous as well as polypetalous. What is the next one? It has got which type of estivation? Valvate estivation, and it has got hypogynous superior ovaries. Valvate estivation, all the families I have mentioned. It is syncarpus. It is syncarpus in nature. It is tetradynamous. Tetradynamous. How many stamens? 6 stamens. Tetradynamous. And which type of placentation? Parietal placentation. This is for you to revise when you have finished. Is it helping you, boys and girls? Tell me. Is it helping you? Yes or no? If it is helping you, then only I will give you. I will not increase your stress. I will not increase your stress. Don't get afraid by seeing this. It will not increase your stress. It will not increase your stress. This is just a revision I am doing where we have studied which example. Once you know morphology very well, after offline classes you will give exams also. So when morphology will be at your fingertips, this will be helping you a lot. Onion and garlic. Onion and garlic is example of bulb and it has got fleshy leaves. Mustard is very important for your syllabus. It has example of bulb and it is an example of fleshy leaves. Coming to citrus, where we have seen citrus as an example, citrus is polyadelphous condition. Citrus is polyadelphous condition. If you remember, Citrus duranta bougainvillea, Citrus duranta bougainvillea, it is thorn, but it is which thorn? Axillary bud is modified into thorn. Okay? Next is your cucumber. Can you tell me where you have studied cucumber? Cucumber is an example of parietal placentation. Cucumber is an example of stem tendril where axillary bud was getting modified into tendril. ECG sahi hai re. It is also an example of epigynous flower. I can see a lot of replies on Zoom that it is helping you and also you are doing with me. Also you are doing with me. P is also another very important example. P is an example of leaf tendril. P is an example of zygomorphic flower. P being Cassia gulmohar, zygomorphic flower. P is an example of vexillary or papilionidae estivation. P has which type of placentation? Marginal placentation. And in P, which condition you can see? Diadelphous condition. Diadelphous condition. Another small one I will just put over here. That is your smilax. Where you have studied smilax? Smilax is an example. No, the smilax only one you have studied. Wait. Banana. Banana is an example of rhizome as well as sucker. Banana is an example of rhizome as well as sucker. Banana is an example of rhizome as well as sucker. Okay? Now, next one. Next one is your China rose. China rose also you have studied many examples. China rose also you have studied many examples. First one is your twisted estivation. First one is your twisted estivation where sepal and petals overlap. Next one, they are hypogynous. They are having superior ovaries. They are hypogynous. They have monoadelphous situation. They have monoadelphous situation. They have alternate phyllotaxy. They have alternate phyllotaxy. I am just writing alternate. They are actinomorphic. They are actinomorphic. And yesterday I made you study they have which type of placentation? Exile placentation. They have which type of placentation? Exile placentation. Next one is your gulmohar. Gulmohar, where we have studied, it is an example of racemose inflorescence. It is an example of zygomorphic flower, racemose inflorescence, zygomorphic flower, and it is imbricate estivation. And it is imbricate estivation. And it is imbricate estivation. Next is your calotropis. Calotropis also many you have studied. One is your valvate estivation. One is your valvate estivation. Another one is cymose inflorescence. Valvate estivation, cymose inflorescence. And you have studied it in opposite phyllotaxy. You have studied it in opposite phyllotaxy. And where else you have studied it? Where else you have studied it? Opposite cymose and gynandrous condition when stamen is fused with gynoecium. Okay? Next is your cotton. Cotton, twisted estivation. Cotton is twisted estivation. Cotton is twisted estivation. It is cymose inflorescence and it is gamosepalous. And it is gamosepalous. Okay, it is just a dictionary. It is just a dictionary. Tomato. Tomato has exile placentation. Tomato has exile placentation. Last class I have said you tomato has exile placentation and it is syncarpous. Cyna papa must eat tomatoes. Next is your brinjal. Brinjal is your gamosepalous and brinjal is your epipetalous condition. Epipetalous condition. Mango and coconut both are drupe fruits and they are hypogynous. So this is all. This is all. This is all. This is all. Also you can write another one. Rose. Rose is apocarpus. Apollo gave lots of roses to Michaelia. And you can also say it is perigynous in nature. I am sure it will help you when you will know all these things at your fingertips. Yes or no? Am I clear or not, boys and girls? Did you like this? Please don't get afraid because I have written so many things, but this is just the summary of your chapter. This is just the summary of your chapter. For remembrance, I have given you tricks also. For remembering, I have given you tricks also. Okay? Yes. Bhaskar pinnately is silk cotton, not cotton. Okay? It is just a revision that yes, we have studied this thing. It will definitely help you when you know at your fingertips. Okay? So I am just sharing you the QR code. After that, let's see, we will meet in offline class. Okay? I am excited to meet you all. Are you excited to meet me? Are you excited to meet me? No? Yes, yes, yes. So this is your QR code. Please scan it and just write it. It is just a dictionary. I have given my best in explaining you. Hope that you have understood. Some extra things I give you because it will help at the last. Don't worry, all these things will be repeated in offline class also. Okay, when offline classes will get started, it will be given to you. Okay, so thank you everyone. Bye bye. Yes, I will miss you too. Thank you so much. Bye bye. Bye bye. Yeah, bye. Bye everyone. Yes, bye. Bye everyone. Bye, everyone. Okay, go and have your breakfast. Bye, everyone. Thank you.